All right, thank you for the introduction. Good to be here. I know it's been an absolutely amazing conference, probably the best blockchain conference I've ever been to, I think, and I don't think I'm alone in that assessment. So today I've brought a presentation that's an amalgamation between some of my own slides and then also some slides that were produced by my inimitable colleague Dominic Williams, who unfortunately can't be here today, but I'm here in his place, and I've got some pretty cool content for you guys. The first thing I want to talk about is give a quick overview of random beacon-based consensus in the way that we have instituted it at DFINITY, and I've just kind of generalized this as random beacon-based consensus. And then I want to talk a bit about product-driven research and development strategy. In DFINITY, we've taken the approach of trying to look at all of the tools available to us from the field of cryptography and use those to build the most performant consensus mechanism possible. And we've based this in the creation of, in the generation of unpredictable, unmanipulable, deterministic randomness. But essentially, we use something called threshold cryptography. So essentially, it's very similar to traditional public key cryptography, only the private key is split into multiple pieces, and once those pieces have been used to sign a piece of data, a majority of those signature shares can be aggregated to create a complete verifiable signature. And we use this to institute a committee-based system that doesn't require leaders. So because we only require a majority of the signatories to generate a signature share and then aggregate those signatures to create a verifiable signature, we can afford to have some of those participants offline or Byzantine without actually jeopardizing the functioning of our random beacon. First of all, bear in mind we have a node base. It's a known, it's a fully registered node base. We use a proof of stake system, and we arbitrarily select our first committee from that node base. And then that committee runs a distributed key generation algorithm that gives it the pieces of the private key and the public key that can be used to verify a signature generated by this committee. And this committee then uses its pieces of the private key to sign the randomness that was used to select it. Then that signature is used as input to select the next committee. And of course, a digital signature being effectively random, or certainly unpredictably random, this gives us the ability to create a random beacon in perpetuity by continually selecting a committee from our node base, and then that committee using its threshold key pair to sign the randomness that selected it. And this can happen extremely quickly. And we use this randomness to drive a number of systems in the protocol. We use this randomness to deterministically shuffle all of the nodes in the network. And the higher ranked nodes, after being shuffled, are more likely to have their block accepted and added to the accepted, signed, and added to the blockchain. The cool thing about this is that we can use the same committee that generated the randomness to sign blocks. And this gives us this amazing, extremely rapid, leaderless consensus system. And this is at the heart of a lot of the work that we've been doing. This has been the foundation of our entire project. We blind the network identities of all of the participants in the network so that no one can be persecuted for participating in the DFINITY network, and also to protect against denial of service attacks. Well, our product is the internet computer, and I love this phenomenally general term because it really just describes a user experience. And that user experience is that of just using a computer that lives in the internet. So the way we look at this is, first of all, what services, what tools are out there that we can use to build this product today. And this is obviously the first place that you look as well-developed strategies and a well-used toolkit. Then we look at what is technologically feasible but has not yet been implemented. And this is where we turn to the depths of cryptography and cutting-edge research. I mean, the sheer number of innovations and the sheer number of things that have become possible now that we have zero-knowledge proofs is just phenomenal. It's totally changed the way that we even think about innovating in the identity space. So we then look at what is these unique possible technologies, these unique possible tools, and these existing tools, and how they can be combined to deliver a product that we consider to provide what we call transformative value. That is, meaningfully transform a market for a specific service. And this then turns into a prospective product design. But in doing so, through this process, you find that in combining all of these different tools, there can be some vague incompatibilities that take us all the way back to the drawing board. And this is a process that within DFINITY we've been iterating on for almost 3 years now, as we move toward this vision of an internet computer that can legitimately disrupt the cloud services industry. And so our platform that, once we've built this platform, right, it has to have customers itself. And who are those customers? Well, they're people who are delivering transformative value to others. And this vision of an internet computer, I'm sure everyone will be able to identify with. It must be fast and scalable. It has to be secure. It has to be aligned with industry standards, existing industry standards. It needs to have extremely easy to use and robust developer tools. And as we've seen with all of these challenges relating to KYC and identity verification, if this is going to be a value-bearing network that interfaces with businesses in the legacy world and meat space, then it is going to have to be able to meet local compliance requirements, and that is going to mean that we need a strong identity system built in as well. So all of these are problems that need to be delivered upon before we can get to that next layer of delivering valuable, usable services to kind of the broader business market. And once we have that, then we've got something that people can use.